All right, number 8, we want to describe the transformation of this graph. So we have the 1 over, looks like x squared. And you can clearly see parentheses here. So this plus 1 is going to shift it left 1. I'm going to go ahead and do the one at the back. That's separate. That's kind of like our k value is going to shift up 1. So I'm going to go ahead and jump down here and do my shift up 1. The negative out front is not with the x, so this is the a. This is going to be a x-axis reflection. And we do not have a y-axis reflection. There's no number there, no negative in front of the x, and there's no number, so there's no compression or stretch in the vertical or horizontal. So none. Now, in this case with the 1 over x squared, if there was a vertical stretch or compression, this number 1 on top would be changed. It would be as if we multiplied something times this 1. So if this is a different constant, then that would give you a stretch or compression. All right, then we want to look at the domain and the range. So let's look at the parent function. Let's start there. So our domain goes from negative infinity to 0 and 0 to infinity. Now if I have a horizontal shift, it's just going to shift my 0 values. Also note my range is from 0 to positive infinity. So if I have a shift there, it's also going to change my range. And we had both. So let's talk about how that changes. So because of the plus 1, our domain, which was negative infinity, let's get that negative infinity to 0. Let me just put the original in there. And then union 0 to infinity. Where? Right here. All right, I'm going to go ahead and put the range in while I'm here. It was 0, and I guess I'll change it when I get there. 0 to infinity, and the 0 was not included. It should have both been in parentheses. Yes. Yes, looking at the right one. Okay, so this is what we started with. Now, because of this, this gave us a shift left. Okay, left indicates minus 1 or negative 1. So we go from 0 to negative 1 in both instances. Now, with our range, we had a couple things happen. It got shifted up, so we're going to start at 1 to infinity, but then this negative reflected it across the x. So instead of going up, your graph is now going down to negative infinity. So it's going from 1 to negative infinity. So let's actually do a negative here. Actually, I'm just going to write the negative here. I got to change the order. So negative infinity to 1 because it got flipped down. And let me see if I can do a visual. Hard to just talk about that and be able to see. So parent function is like this. It's hugging the x-axis really close and then shooting up, and it's doing that on both sides. So this graph got flipped down. So imagine if it was ... going this way. So from 0 to infinity, ... going this way. But that plus 1 shifted up, so that ... is going to be above the line at 1 and then curving down. That's the x-axis reflection, so it's going to be like this and then curving down. So it's going to be above the x-axis. So we're going to cross over, and that's what we're indicating here. Negative infinity, and then goes up to 1 because it's horizontal at 1. All right, so we have completed enough, but we'll continue. The basic graph x cubed is shown. We want to display the graph of x plus 5 cubed plus 2 by dragging arrows. So the minus or the plus 5 is going to shift left 5. So I'm going to grab this and move it left 5 units. The plus 2 is going to shift it up. And so this is the shape that we get now. Here we have the graph of x squared shown, and we want to now graph this one. So we're going to shift it left 3. I want to move on to be on the x-axis. Left 3. We're going to go down 3. And then what this negative 3 is doing is going to flip it. So how do I guess I want to move these points down 1 for right now. So these points are up 1, so down 1, that'll flip it on the x-axis. So imagine that ordered pair. We started here, we can go left 3, 1, 2, 3, and then down 3. That gives us this. Now this 3 here is going to multiply the y-coordinate by 3. So that would be taking this value, which is, so let me try to explain this a little bit different. And this might be just the way that it wants you to graph. And then you can do it several different ways, which I'm going to try to show you some alternative methods as well. So let me grab that calculator while I'm here, because I'm going to need that to show you these other methods. Because right now the technology is graphing most of this for you. And so it leaves a lot to the imagination. Okay, so with a parabola, what I learned when you want to graph, let's just say y equals x squared. Okay, you start on the origin, and then you go up 1, right 1. Okay, so that's 1 and 1, or right 1 up 1, and then you go right 1 up 3, 1, 2, 3. So that's 1 and 3. And then you go right 1 up 1, 2, 3, 4, 5. It's counting by odd numbers. Okay. So this ordered pair, 0, 0. This one will be right 1 up 1, so it'll be 1, 1. And then you add 1 to the x, so that's going to change to 2. And then you add 3 to the y, so that's going to be 2, 4. So you're adding 1 to the x value every time, and then you're increasing the y coordinate by an odd number every time. So if I go right 1 up 1, then I'm going to go right 1 up 3, and then right 1 up 5, and then right 1 up 7, and it continues to go like that. Okay, so let me do one more ordered pair. So right 3, and then we're going to increase that by 5, so it'll be 3, 9. Okay, so I'm going to graph this, and I'm just going to show you that these ordered pairs match. That's the pattern with graphing quadratics. There is a reason for me doing this, because I want to try to mimic that pattern on this graph. Now the only difference is, let me disable the zoom. Only difference is, because of this 3 here out front, it's going to, instead of going right 1 up 1 the first time, it's going to go after the first point, it's going to multiply by 3. So instead of going right 1 up 3, it's going to go up 9. So these should be increased by a factor of 3, I think. But we'll verify it with the calculator. I think they should all be increased by a factor of 3. So it'd be right 1 and then by 3 instead of 1 and then right 1 by 9. So I'm using that to be our standard pattern. So graph, I'm going to go to y equal. I'm going to clear out what I have. I'm going to do x squared, and then I'm going to go second graph to see the table. So if you look at this ordered pairs that I have talked about, 0, 0, 1, 1, 2, 4, 3, 9, and that's because of that pattern. Now, whenever I do it with this guy, okay, it's the same general shape, just we translated it, and then this factor of 3 is going to make it increase much faster, stretch it out. So instead of going right 1, left 1, these points should be right 1 and then 3. I should go 3 instead of a factor of 1. That 1 is going to multiply those by a factor of that 3 is going to multiply by those by a factor of 3. So if I go, let me see, left 1, 2, 3, and down 1, 2, 3. So this is where my parabola is starting. Okay. So if I go right 1, down 1, and I go right 1, down 1, 2, 3, and going like that. Instead of that, our parabola is going to go right 1 and then down 1, 2, 3, and it's going to go right 1, and instead of 3, it's going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. So your parabola is going to get the appearance of looking much, much skinnier. It's going to be inside. That's the stretching because of that number. So we're looking at -3, -3, and then if I go right 1, that's going to be a -2, and then down 3, that's going to be a -2, -6. And then if I go right 1, it's going to be a -1, and then down 9 from here, at 9 here, and it's going to be -15. Okay, so we're going to look for those ordered pairs, but I'm going to graph that whole thing just to kind of show you, and I'm sorry we couldn't see that -115 that I'm writing way down there. And I'm going to just graph this right side. So I think if I move one of these points, the other one will go with it. So I'm going to go to y equal, and this is how you can just check it and verify it. I'm going to clear this out. I'm going to insert the equation that we're working with. So that would be -3, open parentheses, x plus 3, close parentheses, squared, minus 3. The wrong button, close parentheses, squared, and then minus, I get the minus sign, minus 3. All right, we're going to graph it. That's our function there. We're going to go second graph to see the table, just to see a few ordered pairs. And then I'm going to go starting with -3. So I'm going to scroll up for the -3, -3. And then the next point we got is -2, -6. So you see how that y value is still following the same pattern. Right 1, down 1, right 1, down 3, right 1, down 5. You count them by odd numbers. But whatever coefficient you have up front is going to multiply that y value and stretch it in that direction. So you see the 2, 6, and then you see the -1, 15. So those are the ones that we kind of picked out. So that is the pattern that you go through when graphing. So once you flip it by pulling that point down from the, so what I did, it was up, it was going up, and I pulled it just on the downside. And then instead of right 1, down 1, you want to go right 1, down 3. So I'm going to pull this point 1, 2, 3, 2, 3. So that's going to give it the vertical stretch.